Welcome to another edition of CMA 8th Grade Math Academy. Here are our learning goals for today. What will we be learning? Students will discover the volume formula for cylinders and use it to solve real-world problems. Why are we doing this? The formula is vitally important to solving problems involving volume. How will you know when you've been successful? When you're given a word problem, you'll be able to diagram the cylinder and find the volume or a missing length. We're going to be starting on page M587. So go ahead and get that page 87, and we have two cylinders. And the question is identify the radius, diameter, and height of each cylinder. So Mr. Grady took you guys through the vocabulary of this stuff on Friday. Did an awesome job with that. We had our Cornell notes. If you need to look back through your Cornell notes, go ahead and do that. But if you already know how to identify and find the radius, diameter, and height of each of these, then go ahead and do that. I'm going to give you 1 minute to answer A and B. Ready? Go. All right, so let's check our answers here. We have A, we've got this cylinder, and we need the radius, diameter, and height. So for letter A, the radius is already given to us. It is this part up here at the top, because you can tell that that dotted line is going from the outside of the circle to the center. It's not going all the way across, so it is 9 millimeters. Well, we know that if the radius, which is halfway across the circle, is 9, then the diameter is double the radius all the way across, so the diameter has to be 18 millimeters. And the height is given to us right here, so h is 11 millimeters. Okay. All right, that was for B, letter A. Then letter B, it's a little bit different because the cylinder is laying down on its side, but it still doesn't really matter. The only thing you got to pay attention to is the base is always the shape of a circle. So this is our base right here, and they give us all the way across, and they say it's 6 centimeters. So that is our diameter is 6 centimeters because it's all the way across the circle. And if our diameter is 6, then our radius is half of that, so it is 3. And then the 4 is just telling us the height. Even though it doesn't look like a height because it's going sideways, it's still the height of that cylinder because it's laying on its side. So the height is 4 centimeters. Okay? All right, so that was just kind of a review of our vocabulary that we learned on Friday just to kind of get you going. And so now we're going to jump in on the next page to what we're really working on today. So here on page M588, we've got a bunch of different prisms. Now these are shapes that you have seen before. So a triangular prism, then a rectangular prism, pentagonal prism, hexagonal prism. And number 1 says, what pattern do you see as the number of sides of the base increases? So what observations can you make about those shapes as they change, going from the triangular prism all the way to the hexagonal prism? So I want you to take 30 seconds and write something down. Right now you're not talking. You're going to get a chance to share this in just a little bit. So 30 seconds without talking, write something down. What pattern do you notice? What do you observe about those? Ready, go. All right, your 30 seconds is up. Hopefully you have something written down, and now it's time to share that. So now I want you to turn to your partner. We're going to start with partner number 2 today. Person number 2 is going to share their answer, what pattern they noticed, and then partner 1, you're going to respond to that. So now you got 30 seconds to share your answers, starting with partner number 2. Ready, go. All right, thank you for sharing your answers with your partner. Hopefully you guys made some kind of um, observation that the bases of those prisms were adding a side each time. And so you're starting with a triangle, makes the bases of a triangular prism, then a rectangle, then a pentagonal, then hexagonal. They're adding sides. And as it goes down, it's getting closer and closer to look like a cylinder, which is what we are going to be talking about today. So as you think about how you would find the volume of those shapes, and then think about how is that going to relate to a cylinder. Okay, so think about that as you start on question number 2. So cylinders are very similar to prisms, as it tells us in number 2. Their volumes are calculated in a similar way. So A says write the formula for any right prism and make sure you define all the variables used in the formula. So I want you to take a minute, talk with your partner, and come up with an answer together this time. So you're kind of talking together and coming up with what formula can you use to find the volume of any right prism. So any of those above that you could find um, the, the volume with your formula. Okay, coming up with a partner. All right, I'm going to give you guys another 30 seconds. Ready, go. All right, so on number 2 here, you've had some chance to talk with your partner on the formula, and hopefully you came up with something. And hopefully you came up with something along the lines of you need to find the area of the base and then multiply the height. So kind of as a general formula for right prisms, if we know the area of the base, if we know the area of the base and then we just multiply that times our height, that's kind of a general formula that is going to give us the answer to a volume question of a right prism. Okay, so now letter B says make a conjecture about how you will calculate the volume of a right cylinder. Conjecture is just kind of like a prediction or a hypothesis kind of thing. Like what do you think is going to happen? How do you think we're going to find the volume of cylinders today? Okay, so I'm going to give you a chance. You can just write this on your own. You don't need to talk to a partner or anything. You're just writing down what you think is going to happen and how are we going to find the volume of a right cylinder today. Okay? All right. You got 20 seconds to make your prediction. Ready, go. All right, so now we're going to see if you were correct as we go through the rest of this. Okay, so at the bottom of this page, page 88, now we're starting to talk about cylinders. So we were talking about, rectangular prisms, triangular prisms, all those things, and we kind of discovered that it's always just really the area of the base times the height. And it's no different here when we have a cylinder. So if you see, you've got these two cylinders. The one on the left, okay, got a radius of 5, height of 8. Okay, same thing is true here. It's the same one, height of 8, radius of 5. But here they kind of highlighted the bottom section. Okay, and we're going to imagine that this is 1 unit. Okay, so this circle that is darker, kind of shaded in at the bottom, this part of the cylinder is 1 unit tall. So it's like a circle that has a radius of 5 and a height then, or a height of 1. Okay, so really all we have to do for that is calculate the area. Okay, so to find the area of that circle, that part, we know, and you should have learned last year, that the area for a circle is calculated by taking pi times the radius squared. Right? So if our radius is 5, we know that we need to have pi times radius squared, and in this case, our radius is 5, so pi times 5 squared, and we know that 5 squared means 5 times 5, so we really have pi times 25, or 25 pi, and when we multiply that out, remember pi is roughly 3 1400ths. Okay, so when we solve that out on our calculator, we get approximately. So let me change those to the squiggly equals, which means approximately. So that means approximately 78.5 units squared. Okay, they didn't give us units. They didn't give us like inches or feet or anything like that. So we just leave it as units squared. But we still want to have that label, and it's square because we're talking about area. Okay. Now, B says, how many of those discs, okay, could we fit into the cylinder? So if each disc is 1 unit and the height is 8 units, well then, of course, we can fit 8 of the discs into the cylinder, because that's the height. Okay, so then if we move on to the next question, question C says determine the total volume of the cylinder and explain your strategy. Well, just like with those other prisms, we said, oh, it's just the area of the base times the height. Well, the same is true here. So when we take that base, which was approximately 78.5 units, and we multiply it times the height, which is 8, because we're saying we can fit 8 of those discs into that cylinder. Well, when we do the math on that, we get approximately 628 units. Now, this time, instead of units squared, 628 units. This time, instead of it being units squared, because we're not talking about area anymore, we're talking about 3 dimensions, so we have to make it cubed, because it is now cube units instead of just square units. Okay? All right, so there we go. We solved our first volume of a cylinder question. Now, 4 says write a formula for the volume of a cylinder, where V represents the volume of the cylinder, R represents the radius of the cylinder, and H represents the height of the cylinder. Well, we already knew that it was that volume was going to be the base area times the height, which is going to be an h in this case. Well, the base area, which we just did, was pi r squared, so that's what this becomes, pi r squared times the height. And that is our formula that we can use anytime we have a right cylinder. Okay, so on the next page, which is M590, we've got a little scenario, and then a thumbs up, thumbs down, which we know means, okay, we got to do some reasoning here. There might be a right or a wrong answer. We got to figure out which it is. Okay, so at the top, there is a paragraph that tells us what's going on in this box. So we need to read through that. So as always, as I read, when I pause, fill in the blanks. Okay? The director of the marketing department at the company sent a memo to her product development team. She requested that the new prototype equal centimeters cubed. Okay, so two members of the marketing team claim to have created appropriate prototypes, meaning their cylinders that they created hold the correct amount of units, which we know is 602 units and 88 hundredths centimeters cubed. Okay, so two different cylinders. You can see down here, very different cylinders. Okay, very different designs, but both claim that they have the same volume, in the right volume. So it's your job to determine, okay, who is right, and what would you say to them to settle their disagreement? They both think they're right. You got to figure out who really is right and settle the disagreement. Okay, I'm going to give you guys 3 minutes to work through this, okay, and then we'll come back and talk about it. Okay, you got 3 minutes. Ready, go. All right, your 3 minutes is up, so hopefully you realize that you could find the volume of both of those cylinders because they give you the radius and they give you the height, and we know that it's just pi times the radius squared times height gives us our volume. And as you can see, when you take the cylinder on the left, it's pi times 4 squared times 12, and you get, in fact, the correct answer, which is 602 and 88 hundredths. But at the same time, the more of the short and wide cylinder was pi times 8 squared times 3, and you also got 602 and 88 hundredths, so they are actually both correct, and in fact either one would work as the new prototype. Okay? Alright, so we're going to go on to the next page, which is 91, and here's where we're going to get some practice using our new knowledge of solving cylinder volume problems. Okay, so we're going to go through number 2 together, then you're going to do number 3 on your own, and then number 4 we're going to work through together as well. So let's start on number 2, page 91. It says, a circular swimming pool has a diameter of 30 feet and a height of 5 feet. What is the volume of the pool? Okay, so let's go through first and look at what do we need to know and what's important information. So it says diameter of 30 feet. Okay, that's going to be important. We need to know that. And a height of 5 feet. Okay, both those things are the important information that we need to know on this. Now, when we're talking about our formula that we just wrote, that we just discovered, we were using radius, not diameter. So the first thing we need to do is take our diameter, which is 30, and find what our radius would be then. Well, we know our radius would be half, so we know that our radius is actually 15. So don't get caught up in a trick like that where you would use the diameter and end up with the wrong answer. So our radius is 15. So now we can put that into our formula. So we know that it is pi times 15 squared, radius squared. And then our height is 5. So we just take that all times 5. And that's going to give us our answer. So when we take pi, we can take that times 15 squared and then multiply by 5, just like it says. And when we do that, we end up getting an answer of 3,532 and a half. And our label was feet. Everything was in feet, so we're going to say feet cubed. Okay. So again, the only real step we had to do before we just plugged our numbers into the formula was convert that diameter into the radius, which was just dividing by 2. Okay? And then we just plug it into our formula, pi times radius squared times height, and we get our answer. Okay? So question number 3 says, how many millimeters of liquid are needed to fill a cylinder can with a radius of 3 centimeters and a height of 4 and 2/10 centimeters. Okay? All right. So go through carefully, look at what information they give you, plug it into the formula, and solve. I'm going to give you 45 seconds to write down the information you have, plug it into the formula, and solve with a calculator. Ready, go. All right, so in this one, you should have highlighted or circled or something that they give us the radius, which was 3 centimeters, and the height, which was 4 and 2/10. Okay, so this time they give us the radius, so we don't even have to do any converting or anything like that. All we got to do is plug it into our formula. So we have pi times the radius. Well, the radius was 3, so pi times 3 squared times our height, which was 4 and 2/10. And that's going to give us our answer. And when you do the math, you get 118 and 692 thousandths. And that is centimeters. And again, it's cubed because we're talking about volume, so you need the centimeters cubed sign there. So that is our answer for number 3. Now we're going to go down to number 4. Number 4 has several more steps to it. Okay? And so we're going to go through this one together. Okay? So this is kind of a long problem, so as I read, when I pause, I want you guys to fill in the blanks. Ready? Here we go. Many newspapers are made from wood. The wood used to make this paper come from trees, which are typically about feet tall and have a diameter of about foot. However, only about of each tree is turned into. Suppose it takes about cubic inch of wood to make 1 sheet of. About how many sheets can be made from a typical tree? Show your work and explain your reasoning. All right, so a lot of things going on here, a lot of important information. Okay, so let's start up at the top. Many newspapers are made from 100% wood. Yeah, that's important, but that doesn't tell us anything about how to solve the problem. Now, when it gets down to telling us about how tall the tree is, yeah, that's important. So 60 feet tall, diameter of about 1 foot. Okay, that's important. Okay, another thing that's important is only about half of the volume of each tree is used. Okay, so we're really talking about half of whatever volume we find. Okay, and that's to find out how much each tree produces. And then the second part of that is, suppose that it takes about half a cubic inch of wood to make 1 sheet of paper. Okay, so we'll get to that in a second. But first, I want to get through this part, which is how much volume is really in that tree and how much of that volume are we using. Okay, so if we know that tree is 60 feet tall, that's going to be our H. But it gives us a diameter, right? It gives us diameter of a foot. But if the diameter is 1, then that means the radius is a half of a foot. Okay? So that is what we're going to plug into the formula. So we know that it is pi times 1/2. Pi times 1/2 squared times the height, which is 60. Okay? And I'm not going to do that yet because then it also says that we only use half of all of that. So I'm going to do all of this in parentheses and then divide by 2 because only half of the actual volume is used for each tree. Okay? So I know that looks kind of confusing, but all I did was I took the volume formula, which is pi times radius squared times height. Our radius was 1/2 and our height was 60. But then it said that half of that answer is what we use for paper. So this equation that I wrote out is really the amount of each tree that we're going to use to create paper. Okay? So when we do that, when we take pi times 1/2 squared times 60, and then we divide that answer by 2, we end up with an answer of 40 and 690, or sorry, 40,600 94 and 4/10. And that is inches cubed. Okay? So that is the amount of the tree that we can use to create paper. Okay? But that's not all that we need to do yet, because then at the bottom it says, suppose it takes about a half a cubic inch of wood to make one sheet of paper. Well, if it takes a half an inch, that really means that each one of these inches, each one of these 40,000 inches that we got in the first part, each one inch of those really makes 2 sheets of paper. So if we take this whole answer and multiply it by 2, so we take our 40,694 and 4/10 and we multiply it by 2 because each one will make 2 sheets of paper. We get 81,389 approximately sheets of paper. So that is really our final answer. So we did all that work to get our sheets of paper, which was just over 81,000 sheets of paper from one tree. All right, you guys are doing good. We've got one more thing here to do, and that is on page 91. It's at the bottom of M591. Okay. So these problems are a little bit different because we already know the volume. So it says right here in the problem that each one has a volume of 500 centimeters cubed. So we already know the volume. Well, to this point, all we've been doing is finding the volume. We've been given the radius or diameter or something like that and the height, and then we found the volume. But now we know the volume, but we're going to have something missing, whether it's the height or the radius or the diameter or something like that. Okay? So the first thing we need to do on these is kind of figure out what we know, what we don't know, and then find out what we're really solving for. So let's look at letter A first. So A is a cylinder. Even though it's on its side, it's still a cylinder. And it tells us that the height, because the long side connecting the two bases is 13, so that's the height. And the radius is just r. It's not given to us. So the radius is what we're going to find. So let's write this out as the formula, just putting the pieces in that we know. So we know it's pi. Pi is always pi, 3 and 1400ths, times the radius squared. We don't know what the radius is, so we're just leaving it as r, times the height, which is 13. And that's going to give us the volume. Well, we already know the volume is 500, so instead of saying v or some other variable, we're just going to write in 500 because we know that's the answer. Okay. Now, if we were given this question and we were supposed to solve for r, we would just isolate the variable r, get it all by itself, and we'd have an answer. So that's really what we're doing. So all we would have to do here is set this up like just solving an equation. So draw a line. Okay, well, the opposite of multiplying by 13 is dividing by 13. So we'd have to divide both sides by 13. Then we'd have to divide both sides by pi. So we're also dividing by pi here and getting an answer. Okay, so when we do that, when we take 500 and divide it by 13 and then divide it by pi, let me give you a second to do that in your calculator. So go ahead and do that. So 500 divided by 13 divided by pi, and we get 12, and I'm going to round it to 25 hundredths. Okay, that's what we get on the right side. Well, these pi's canceled out, these 13's canceled out, so now all we have is r squared. So if r squared equals 12 and 25 hundredths, we know that the opposite of squaring something is square root. So if we do the square root of 12 and 25 hundredths, we get 3.5. So we know that r equals 3.5. So that is our answer. So I'm going to write it over here. R equals 3.5, and everything was in centimeters. So R equals 3.5 centimeters. Okay, so that's all we had to do. So now as we go to letter B, this time it's not a cylinder. It's a rectangular prism. Well, we know that it is base area times height. Well, base area is just going to be length times width equals the base. So length times width times height is going to give us our volume. But again, we're not given the height. We're trying to find the height. So it's really 3 times 4.5 times height equals 500. And again, we're going to solve this to find the height. Well, we need to divide by 3 times 4.5, divide by 3 times 4.5. And when you take 500 divided by 3 and then divided by 4.5, you get h is equal to, we're going to have to round it because it kind of comes out to be a long decimal, so it's 37, and we're just going to round that to 4 hundredths. Okay, so 37 and 4 hundredths. So for BH equals 37 and 4 hundredths centimeters, and that's our answer. Okay. All right, so following that same pattern, I want you guys to give C a try. We're looking for the diameter, we're given the height, and we know the volume. Okay, I'm going to give you 1 minute to solve this one on your own. Ready, go. All right, so for letter C, we know we're going to use the same formula as we did on letter A. So we know it's going to be pi times radius squared times the height, which in this case is 5, equals volume, which is in this case going to be 500. Okay. So again, we just need to use inverse operation. So we need to divide by 5 pi and divide by 5 pi. 5 and pi. I'm just combining two steps there. Instead of taking 500 divided by pi and then dividing it by 5, I'm just doing it all in one step. When we do that, we get r squared is equal to 31 and 85 hundredths. I'm rounding that one again because it was a long decimal. And then when we find the square root of that, because we're trying to find r, not r squared, r equals 5 and 64 hundredths. And so we're almost done, but on this one we're not looking for the radius. They want to know the diameter, so to get diameter we multiply by 2. So when we take the radius times 2, we get 11, and when we round, 29 hundredths. So our answer is diameter equals 11 and 29 hundredths centimeters. And that's our answer. Okay? So now you've been able to find the volume when you're given the radius, diameter, and height. And now you can go work backwards. You can start with the volume and work backwards using the formula to find either the radius or diameter or height. So now you are completely prepared to solve any questions about cylinder volume. And that is what you are going to do for your homework on page 97. So this is M5 97. You're going to do the middle box that says practice, where you see all the cylinders. You're going to do questions 1, 2, and 3. You can go ahead and get started on that now. Whatever you do not finish is homework due tomorrow. All right.